Hello everyone. Today we're going to be looking at another additional topic, that being arithmetic sequences and series, and I'm going to throw in one application. In the normal setting we probably would have taken a couple days to do this, but these are things we've dealt with before, maybe just we don't know the name, or maybe we do. But a sequence, I think we know, is just going to be a list of things. If we're looking at an arithmetic sequence, what we're looking at is a list of numbers, and there's a pattern that's formed in those lists of numbers, and the pattern is that you're either adding or subtracting a fixed number every time. So a sequence is just a list of numbers, and the list doesn't have to follow a pattern, but when it's an arithmetic sequence, then the list of numbers is formed by adding a positive or adding a negative, which would be subtracting a fixed amount to get from one term to the next. And the fixed amount that we add, again, or subtract to form our arithmetic sequence is called a common difference, which is the same difference that we find from one number to the next. And we use the letter D to represent that common difference. So for example, in number 1, we have a list of numbers here, so it's a sequence, and there's a pattern in the sequence. We can see to get from 2 to 6 we're adding 4, to get from 6 to 10 we're adding 4, to get from 10 to 14 we're adding 4. So we would say that this is an arithmetic sequence because there is a common difference of 4 to get from one term to the next. So if I continued to add 4, 14 plus 4 would make 18 the next term, and then 18 plus 4 would make 22 the next term, and we can continue using that same pattern. Okay, number 2, another sequence of numbers here. What are we adding to get from 3 to negative 2? Well, technically we're adding a negative 5, or we are subtracting 5, right? To get from here to here, we're subtracting 5 again. We could continue to subtract 5. So we would say that this is an arithmetic sequence with a common difference of negative 5. If we're subtracting 5 every time, we are adding a negative 5. And so going forward, negative 12 minus 5 would make negative 17 the next term. Minus 5 would make negative 22 the next term. And if I had to go and get the first term on this list to work backwards, I would have to add 5, which would mean 8 would have been the first term on that list. Okay? So an arithmetic sequence is just a list of numbers. It's formed by adding a fixed number to get from one term to the next. Now, if, like in number 1 and 2, I asked you to find, the first term, or let's say the 4th or 5th or 6th or some term number on the list that's within a reasonable distance, it's pretty easy to just add and subtract to get there. But if, let's say, I wanted to know, the 100th number on the list, I don't necessarily want to add 4 100 times to try to get out there, or however many number of times. I don't want to have to add or subtract to get to a number that's farther down the list. So we have something that we can use to find a specific term in that list, and we call it an explicit formula. So an explicit formula is a formula that can be used to find a specific term in the sequence. And sometimes you might be asked just to write a formula to represent the situation, and then if we wanted to find a term number on the list, then we would actually use the formula. But if all we're going to do is write it, the formula is this. This is our formula, explicit formula to find a term that's on the list. If we wanted to write an explicit formula for a specific list, then the only variables that would be replaced there would be D, which is our common difference, and then a sub 1, or in either order. A sub 1 representing the first number on the list. So let me get rid of the box. A sub n, that's notation for any term on the list. A sub 1, that would be notation for the first term that is on the list. D, we talked about a few minutes ago, is our common difference. And then n represents the term number. Okay? So if we wanted to write an explicit formula, it's that formula with something plugged in for a sub 1, our first term, and something plugged in for D, what is our common difference. But the n minus 1 and the a sub n would stay. Now if we actually wanted to use the explicit formula, which is a little more purposeful, so that we could find a specific term number, then we would be plugging in n as well. So we would still plug in a sub 1d, but we'd also plug in the n, and then we'd be able to figure out what that term number is. Okay, so let me show you how to do both of those things. If we're going to write the explicit formula for this sequence, all I need to know is the first term, And the first term on my list, the first number on my list is 3. And I need to know the common difference. What are we adding to get from one term to the next? Well, I can see to get from 3 to 8 or 8 to 13 or 13 to 18, what we're doing is we're adding 5 every time, so our common difference is 5. So if I wanted to write a formula to represent this list, we would say a sub n, that's any number on this list, is a sub 1, which we know is 3, plus our common difference, which we know is 5, multiplied by n minus 1. So that's what the formula would look like for that list. Now if I wanted to use it to find a number on the list, then I would plug n in as well. So if I wanted to, let's say for example, find the 50th number, then I would be looking for a sub 50, and it would be 3 plus 5 times 50 minus 1, and then calculator spits out the number, boom. Okay, so that's just writing it. That's all we were asked to do in number 3. Number 4, we're actually going to use it. So if we want to find the 50th term in the sequence, using the explicit formula, we still have to know the first number on the list, which is 12. We still want to know the common difference. What are we doing to get from 12 to 8 or 8 to 4? We are subtracting 4. So common difference is negative 4. But now we also have to know the term number. Okay, well, we're looking for the 50th term on the list, so n has to be 50. So now we're going to plug all 3 of those items in. So we're looking for a sub, not n, but a sub 50. We're looking for the 50th term on this list. It's going to be a sub 1, which is 12, minus 4, because our common difference is negative this time, multiplied by n minus 1, so 50 minus 1. And then this portion here is just going to go into the calculator, so that we could say a sub 50 is, and let's pull out the calculator here, okay? Now, it's not that that's hard work to do by hand, but one less place to make a mistake if you just go ahead and put the whole thing in the calculator. So 50 minus 1, and the 50th number on this list would be a negative 184. So we would say a sub 50 equals a negative 184, okay? So we were asked to find the term number here. There it is. We were just asked to write the sequence here, and there it is. All right, so there's one for you to try. Feel free to pause the video and give it a shot. Otherwise, let's see. We've given all the information that we need here. We're looking for a sub 100, so we know n is 100. And we're given a sub 1, we're given d. So a sub 100 is going to equal a sub 1, which is 10, plus the common difference, 6, multiplied by n minus 1, so 100 minus 1. And again, we're going to put this portion into the calculator. So we're going to say a sub 100 is, what is the 100th number on this list that starts at 10 and continues by adding 6. So we have 10 plus 6 multiplied by 100 minus 1. And there it is, 604. So 604 is the 100th number on the list. Okay? So that's the explicit formula. Again, we can just write a formula to represent a situation here or represent a sequence, or we can use the formula to find a number in the sequence. We also have what we call a recursive rule. It's also a formula, but not really as helpful as the other. The recursive rule is basically just showing the pattern. It's a mathematical way to show the pattern or state the pattern for a specific sequence. And it's, to me, this one is, again, it's not really useful. We don't really do anything with it. It's just to state what the pattern is. But the pattern here in these arithmetic sequences is pretty simple. All we're doing is we're taking a term and we're adding something to it every time. Just how you say that can be a little tricky if you, once you see it, you'll get it. But if you were trying to come up with this on your own, it might be a little tricky. So what we want to say, let me just take it to number 5, and you don't need to write this just yet, but what's the pattern in number 5? Well, to get from 18 to 23 or 23 to 28 and so on, we are just adding 5, right? So I want to say that for this particular list, to get from one term to the next, I'm adding 5. So we could say any term on this list, let me do this in words first. Okay, any term is the previous term plus 5, right? And for this particular list. So what we want to do is replace this any term with some notation. Is, we know how to replace that, that's an equal sign. And then the previous term, I meant to put the term there, right? We need to replace that with some notation. And then the plus 5 right? That's just going to be a plus 5. So we want a mathematical way to say that any term in this list is the previous term plus 5, right? If I wanted to get to 23, I took the previous term of 18 and I added 5. Or if I wanted to get to 28, I took the previous term of 23 and I added 5. So any term on this list, we actually saw that in our explicit formula, we could say is a sub n. The question is, how do I say the previous term? So let's say it was the 7th term, the previous term would be the 6th term, right? Or if it was the 8th term, the previous term would be the 7th term. So if any term we're looking for is n, the previous term here is 1 less, right? 7 then 6 is 1 less, 8 then 7 is 1 less. So this is going to be a sub n minus 1. Okay, so we could say any term on this list is the previous term plus 5 using this notation. Or to make this more general, our common difference. Okay, that's what we're going to be looking at as a formula for this situation. Now let me get rid of all my craziness here. And let's go back and fill in that bullet point. So the recursive rule, to write a recursive rule for a situation, all we need to do is plug a common differences, that's the only thing that's going to change from one arithmetic sequence to another, into the formula that says any term is the previous term plus that common difference. Now we also have to state our first term so that we know where our list starts, and then this is a recursive rule that shows us what the pattern is going to be. Okay, so how will this look for number 5? For number 5, our common difference we said is 5. So we say here's a list that starts at 18, and then any number on this list would be the previous number plus 5. Okay, so same thing here for number 6. We would say the common difference here, what we're doing is subtracting 1. So we say we have this list, a sub 1 is 5. We have this list that starts at 5. And then any number on this list, we could take the previous number and subtract 1. Okay? Or again, feel free to pause and try this out. We are adding 7. So D is 7 here because we're adding 7 to get from one number to the next. We would say the first number on this list is 4, and then any number on the list would be the previous number plus 7. Okay, now I don't want to confuse you too much if you're perfectly happy with that version of it, although if you were looking this up in another video, you might see another form of this. We could also say that the next number on the list is the previous number plus the common difference. So any number plus the common difference would get you to the next number is what that's saying. So that's another version. Either one of those is acceptable. They both are fine. I just prefer the first. It makes a little more sense to me. But either one makes sense as long as you state the first term in your situation. Okay? So we have an explicit formula to find a term number. We have a recursive rule. It's technically a formula, but I like to call it the recursive rule because it's just showing the rule or showing the pattern. And then we have another formula we're going to look at, which we're going to connect to arithmetic series. So a sequence is a list of numbers. An arithmetic series is the sum of that sequence. So if we took the list of numbers and we added them together, that would be our arithmetic series. So an arithmetic series is the sum of an arithmetic sequence. And if we want to evaluate, that means if we want to actually find the value of the sum or figure out what the sum of that sequence is, we have a formula. So the formula here, notice it starts with an S for sum. So the sum is going to require us to know 3 things. We have to know n, which is our term number. We have to know a sub 1, which is the first term, and then a sub n. If we were looking for, let's say, the 40th number on the list, right? We'd have 40 over 2 here, and then we'd have some first term, whatever it is. And then a sub n would be a sub 40 again. So this a sub n is going to always represent the last number in the sequence. Okay? So what we need to know if we want to evaluate a sum is we need to know the first number on the list, we need to know the number of terms, and we need to know what the last term is. So we need to know n, a sub 1, and a sub n. So again, n is our term number. A sub 1 we know is our first term. And a sub n is going to end up being our last term. Okay, so pretty straightforward then for number 7. If we want to find the sum of this list, notice the plus signs in between here. Now we could still use the commas like we did on number 8 and number 9, but when it says to evaluate the sum, that means we're adding up the numbers on the list. So find the sum, we need to know 3 things, and we have them all here. We need to know the number of terms, which they tell us is 12. We need to know the first term, that's given to us as 1, and we need to know the last term, a sub n, which is a sub 12 in this case, and that last term is 45. So those 3 pieces get plugged into our sum formula. So we would say the sum for these 12 terms is going to be 12 divided by 2 multiplied by a sub 1 plus a sub n. So we're going to look at 1 plus 45. So the sum for these 12 terms, I'm just going to go to my calculator now, again, just to avoid any mistakes. So I know 12 divided by 2 is 6, but I'm just going to let my calculator do all the work. So 12 divided by 2, and then in the parentheses 1 plus 45 means the sum we're looking at is 276. So if I added those 12 numbers on that list, I would get a sum of 276. Okay? Now number 8, you're going to see is a little more complicated. We are asked to evaluate the sum, and we need 3 things. I need to know how many numbers on the list, which right now is a problem. So I know where the list starts, I know where it ends, but I don't know how many numbers are on that list, right? I don't know how many numbers are missing in that ... If we wanted to just try to continue the list, use the pattern to fill it in, we could, but that might take a little while. So let's leave n as a question mark right now. I do know the first number on the list is negative 50, and I do know the last number on the list, but I don't know what n is, so I'm going to leave it a sub n. I do know that last number is 400. Okay? Now again, if we wanted to complete the list, that'd be a long way about going about this process, but we could do that. However, we have a formula we looked at on the front that could help us figure this out. So the formula, the explicit formula we looked at said a sub n was a sub 1 plus d times n minus 1. Well, n is the piece we're looking for, and I know the rest of these pieces. I know the common difference, I know the first term, and I know the last term. So if I plug all those pieces in, 400 would go here, negative 50 would go here. Common difference, we are adding 15 every time, so plus 15 would go here, and then n stays in as a variable, and now we can solve for n to figure out how many numbers are on that list. So I'm going to add the 50 over, and that would give me 450 equal to, if I distribute this, 15n minus 15. Now I'm going to add the 15 over, so 465 is equal to 15n, and now divide the 15, so n is equal to 465 divided by 15 was 31. So now I know that n is 31. So there's 31 numbers on the list. Now I can find my sum. Now I have the variables I need there. So we're looking for the sum for these 31 terms. So we take 31, divide by 2, and multiply by a first term plus the last term. And calculator is going to do the rest for me there. So I have 31 over 2, and then multiplied by negative 50 plus 400. And so the sum of the numbers on the list is going to be 5,425. 5,425. Okay, so number 9 is a very similar process if you want to pause and give it a shot. But something similar is happening in number 9. I'm going to see if I can squeeze it into this little space. So we want to find the sum of the first 30 terms. So in this one, I know the number of terms is 30. And I know the first term on the list, a sub 1, is 3, but I don't know the last term. I don't know a sub 30. Like, what is that last term? But again, we have an explicit formula that we can use to find a term that's on the list. So the explicit formula says a sub 30 should equal a sub 1 plus, the common difference here is 5, and we multiply by 30 minus 1. And so a sub 30 is going to equal, calculator, 3 plus 5 parentheses 30 minus 1, so 148. So 148 is the last number on that list. So now I can find the sum for those 30 terms. It's going to be 30 over 2 times first term was 3 plus last term we said is 148. And that's going to make that sum, let's see, 30 over 2. Again, I know that's 15, but I'm just going to try not to make any errors here. 3 plus 148 in the parentheses, 2,265. 2,265. If I added all 30 of those numbers together, that would be my sum. Okay? So it's a formula, sometimes really straightforward to use, like on number 7. Sometimes you've got to use the explicit formula first. Now there's a long way to do each of these, right? If you just wanted to make the entire list of numbers and add them all together, you could absolutely do that, but the formulas are to help us shortcut that process. Now, you could be asked to find the sum using something called sigma notation. So if you're looking at number 10, this is asking us really to do the same thing that we were just doing in 7, 8, and 9. This is asking us to find a sum. They're just giving us the explicit rule and telling us where to start the list and where to end it. So the symbol that we're seeing here that looks kind of like an E, this E-looking symbol, that's called a sigma. It means sum. So when you're looking at this expression here, this expression is saying find the sum of a sequence where this is the rule for the sequence, this is where it starts, so we want to start at the first term, and this is where it ends, so we want to end at the 25th term. So this is saying find the sum of the sequence formed by 3n plus 4 as the explicit rule. So find the sum of the sequence where this is the rule, and it starts at the first term and ends at the 25th term. So we're looking for the sum of 25 terms formed by that particular rule. Okay, so if we want to find the sum, we still need the same pieces that we did before. We know, like in number 10, or in each of these, where the list starts and ends. So I know, like, here there's 25 terms, here 25 terms, here 18 terms, here 30 terms. And so I need to know the number of terms if I'm going to use my sum formula that I just looked at a few minutes ago. But I also need to know what the first term is. Oops, pen. What the first term is and what the last term is. So I'm going to have to calculate those by hand and then plug them into the sum formula. So for example here, I know that the number of terms in the list, if we're starting at 1 and going to 18, is 18. And then the first term I can calculate. The first term I would find by plugging a 1 in for n. So 4 times 1 minus 6, which is going to be 4 minus 6 or negative 2. And then the last term on the list would be the 18th term, and I can find that by plugging an 18 in for n. So 4 times 18 minus 6. And 4 times 18 is 72. 72 minus 6 would be, what, 66? Let me not screw this up. 4 times 18. Don't trust my at-home math. Okay, good, 66. Sometimes I can still multiply and subtract. Hallelujah. All right, so those 3 pieces are the ones I need to find the sum, which is what this is asking me to do. All right, so now that I have all the information I need, I can find the sum for these 18 terms. It is found with 18 divided by 2, multiplied by the first number we said was negative 2, and the last number, which was 66. So the sum for these 18 terms, again, not risk messing this up, 18 divided by 2, multiplied by negative 2 plus 66. So the sum is going to be 576. 576. Okay, now not hard work, but it's work that you don't necessarily have to do, because this can all be plugged directly into my favorite, Desmos. Okay, so Desmos that I was using to make these calculations actually has a sigma notation in it. So I'm going to show you how to do this in Desmos. I'm going to verify the one that we just completed. So when I go here, there's no sigma on my home screen here on my keyboard, so I'm going to hit Functions. And if you go into Miscellaneous, down toward the bottom row there, you can see the sigma symbol. So I'm going to tap the sigma symbol, and it says start at, we said 1, n equals 1. Tap on the top of the E there, the sigma, and put in the 18. And then here, we want to make sure we use parentheses to put in 4, and gotta use an n for n, and then minus 6. And then we close out the parentheses, and it says the sum of those 18 terms is 576. So we did that by hand, not hard, but definitely easier to just type it into Desmos. Okay, so now if you want to pause and give number 11 a shot, I'm gonna do this again. Functions, sigma, this time we're going from, now this time we have x in here. I'm still gonna type it in with n, just make sure that you use n when you write your explicit formula. So we're gonna go from the first term to the 30th term, and then in parentheses, 5 minus 2 n. If you try to type an n underneath the sigma and then an x inside of your explicit formula, it's not going to do anything for you. So make sure your variables match. So you can either change the x to an n, or you can change the x here, or change the n in your sigma to an x. So either way, as long as the variables match up, it'll work. So the sum for these 30 terms is negative 780. So, oops, let me just, for you here, make sure that when you're using Desmos, put parentheses here, and then make sure that the variables match. So use n for both, or x for both, but they have to match. Okay, so this one, calculator says, I forgot, negative 780. The sum for these 30 terms is negative 780. Okay, so you have the option to just use Desmos, and really, you could use Desmos and sigma notation for the rest of these. So if you know, like for number 7, that we're going from the first term to the 12th term, and you wanted to write the explicit rule, I don't think it's any more or less work than just using the other formula. But if you wanted to use sigma notation on these as well, you could. Just have to figure out how to write it with the sigma notation first. Okay, so you have the option of working by hand, you have the option of plugging into Desmos. All right, so one application, you can just see, not that this is the best application, but there are some places where some of these formulas are actually useful. We've got Bob. He does 10 push-ups on the first of 30 days this month, and his goal is to do 2 additional push-ups each day. So if he meets his goal, how many push-ups will he do on the 30th day? And then how many total push-ups will he have done over the course of the month? Hopefully you recognize this is an arithmetic sequence. So day 1 of the month, it says he does 10 push-ups, and he's going to do 2 additional each day. So 2 additional each day means the next day he's going to be doing 12, and the next day he's going to do 14, and then every day of the month he's going to keep adding on push-ups. There are 2 push-ups per day. So if he meets his goal, how many push-ups is he going to do on the 30th day? On the 30th day would be like, what's the 30th number on the list? So here we are looking for a sub 30. That is the question. Okay, so we have this explicit formula. It says a sub 1, or a sub n is a sub 1 plus d times n minus 1. So we're looking for a sub 30. First number on the list was 10. We're adding 2 push-ups for 30 days. So we go into our calculator, we say, okay, what's 10 plus 2 multiplied by 30 minus 1? Oops, how about 30 minus 1? It says 68, which means over the course of these, or on the 30th day, he's going to do 68 push-ups. Now, if this had no context, you would just answer a sub 30 equals 68, but here it represents push-ups, so we're going to say he's going to do 68 push-ups. Okay, 10 push-ups on the first day didn't seem so bad, but 68 push-ups on the 30th day, I don't know that I could do 68 push-ups. I guess if I had the entire day, but no way in one shot. Okay, so part B, how many total push-ups is he going to have done over the course of the month? Total push-ups means if I added up all the push-ups he did on all 30 of those days, how many would he have done all together? So this question is asking what's the sum for the 30 days? Okay, so our sum formula says the sum of n terms is n over 2 times first term and last term. So the sum for the 30 days would be 30 over 2. First number on the list was 10, and fortunately in part A we figured out the last number on the list was 68. So now if we plug that into the calculator, we're going to figure out the total number of push-ups. So 30 divided by 2, and again I know it's 15, but don't want to make any goofs here. So 10 plus 68 in the parentheses says 1,170 push-ups. 1,170. So over the course of the month, he's doing over 1,000 push-ups, which is pretty significant. Push-ups. And this was on day 30 here, and this was all together here. Is that one word? All together? How about when you don't know how to spell a word, you pick a different word. Total. Over 30 days. I think I mentioned that strategy of mine before, right? If you don't know how to spell a word, you pick another word. Okay, so total over 30 days, and that was on day 30. All right, so there it is. Hopefully the practice is pretty straightforward.